Alright class, so in this chapter, section 3.3, they simply want you to graph to determine the type of system. And so there's basically three types of systems that I mentioned in the notes. The one system has one solution where the lines intercept, and in this case we are dealing with one solution. And you can determine this by graphing, which is what they essentially want you to do. Now, you can graph this however you wish. My suggestion, and I've shown you how to do this with Desmos, is if I go ahead and I graph that particular equation, that's what it looks like. Alright, you can see the one solution is right there. It's an approximate number in this case because I gave you some off the chain kind of calculation, but it's still an XY, it's still a coordinate, and that's where they intercept. In the event that you have parallel lines, that's a second type of system, so let me go ahead and draw that for you first. And what we remember of a parallel system is they have the same slope, so there's an example of parallel lines. In this case, you have no solution. And furthermore, if you have the same line, you have infinitely many solutions, because it's the same line over itself. So the first system, one solution. The second system, you're looking for parallel lines. So if this is a 3x plus 5, the second line could be equal to anything 3x plus whatever. It doesn't matter. But the case in point is they're parallel lines because that slope is identical in both cases. So you have parallel lines here and such. They look practically identical, just side by side. In this case, you have no solution. Alright, and then the next example that you had, which was the same line, and so let me just write here, parallel lines, so you're looking for the same slope. Alright, and then the last solution is infinitely many solutions. So infinitely many. Oh my god. Hang on a second, that's not possible. Infinitely. I'm having a brain. Infinitely. Oh, I misspelled that too. Many solutions. In which case we have the same line over itself. So you draw the same line, and then you readjust the second one, and you notice that the second one is just simply an overlapping line just written differently. So in this case, if I have y equals 3x plus 5, and the second line might be negative 3x minus 5 equal to y, and then once you readjust this part of the line, you'll find that it is the same line as this, in the yellow, right? And so those are the three types of systems that you're looking for in this particular chapter. Now, in 3.4, which I'm going to do right here as well, because they are related, you're using solutions for these values. So in other words, if I'm solving for x as an example, if I have two equations, if I have y equals 3x plus 5, and I have another line which is y equals 1/2 x minus 3, I simply set both of these equal to each other. And if I do that, I have 3x plus 5 is equal to 1/2 x minus 3. And you do that because y is equal to y, therefore this is equal to this. If I subtract the 1/2 x on both sides, I will subtract the 5 and move that to the other side. So if you notice, the 5s are going to cancel, the halves are going to cancel, and you're left with, in this case, 2.5, so 2.5x is equal to negative 8. And I'm going to divide by 2.5x, or 2.5, leaving the x. And so this will cancel, leaving you x equals negative 8 divided by 2.5, and at least you have the x value now. You then take this x value, which is an odd decimal, and plug it into any one of these x's you choose. and then you solve for y, and you get your y equals. And if you notice on the diagram, you have already the solution. Let me go back and change this to negative 1/2. Alright, and if you click on the solution, you see what you get. And I believe this was a +3, wasn't it? Or was it minus? There you are. That's what you got. So that's what your negative 8 divided by 2.5 is going to give you. And then when you plug that negative 8 in here, you're going to get that. Now in your book and in your test, you typically are going to have very friendly numbers. So you won't have numbers that will play out so weirdly. Now, the trick to this is that for this one, you're going to get simply a coordinate pair. You're going to get some x value and some y value, and you're good. That's done. You've solved the system. How you know that this is parallel lines is that you're going to get a value such as 8 is equal to 6, and that is not possible. And over here, you're going to get something like 6 is equal to 6, or 8 is equal to 8. Whatever it is, happy face is going to equal happy face. It doesn't matter. The point is that you're going to see the same thing on both sides of the equation. And that's how you know that you are solving infinitely many. As for the process, it's the same. So remember, that's no solution, so it would make sense that you would end up with that type of response. Alright, so I'm going to go ahead, I'm going to stop this video here. I think that's clear enough. If worst case, I would look at the chapter section and ask me questions.